Namaskar. Very good morning to all of you from India. Welcome back to the VCDRR session. So this is Keynote session 5, which will be chaired by Dr. Arvind Kumar Jha. So once again, welcome to all the speakers, participants, and session chair. Let me briefly introduce the session chair and hand over to Dr. Arvind. Dr. Arvind Kumar Jha is an assistant professor at IIT Patna. He completed his PhD from Indian Institute of Science, Bangalore. And he also served as associate professor in the Department of Civil Engineering at Manipal University, Jaipur from 2017 to 19. And there are several awards to his credit, such as ISSMG Foundation Award, then International Scholarship for PhD by Indian Institute of Science, Bangalore. Basically, he hails from Nepal and he did his PhD at IISc Bangalore. And MSc grant, dissertation grant by National Academy of Science and Technology, Nepal, etc. And he is a member of various organizations such as ASE, Indian Road Congress, Nepal Engineering Council, Nepal Geotechnical Society, etc. With this brief introduction, I will hand over the session to Dr. Arvind Kumar Jha. Arvind, please.
Thank you very much, Srivalsa ji, and thank you very much organizing team for giving me such an excellent opportunity to be a part of this prestigious conference. So good morning to all from India. So it's really my pleasure to welcome you all in the very important 5th keynote session of VCDRR 2021. So in this session, we have the 4 keynote lecture, which will be delivered by the eminent speakers. And I hope all the speakers are well aware with the guidelines, particularly for to complete his presentation on the time. And you have been given 18 minutes to conclude your presentation. And to the audience, if you have any question, you can drop your question in the chat box, and we'll pick your question depending upon the limitation of time. Okay, so without further delay, let me take this opportunity to introduce the first speaker of this session, Dr. Arjun Sil. Okay, so Dr. Arjun Sil, presently assistant professor in the National Institute of Technology, Silchar. His specialization are earthquake engineering, including structural, geotechnical, seismology, microzonation of urban centers, multi-criteria decision, uncertainty modeling, performance-based design, risk and reliability constitutive modeling, elasticity and plasticity, numerical modeling, slope stability, GIS, RS, geophysical experiment, landslide hazard assessment, extreme modeling, blast load modeling, pollution and corrosion modeling. And he is also an active member of different professional societies and the bodies and institutions. And he is a member of American Society of Civil Engineers, member of Seismological Society of America, life member of Indian Geotechnical Society, member of Institution of Engineers, India, member of International Geosynthetic Society. So with this brief introduction, I'll request Dr. Arjun Sil to continue with his presentation.
Yeah, so very good morning to all, and thank you, Dr. Jha, session chair, and special thanks goes to Dr. Srivalsa Kolathar and his team for inviting such a great conference on online mode. So I thank the team, the whole team. So now, yes. So can I move for the presentation?
Yeah, sure.
Okay. Yeah, so my slide is visible.
It's visible. Yeah, perfect.
Okay. So very good morning again to all of you. I will mainly discuss my topic, that is the estimating service life deterioration of earthy bridges due to multi-hazards in Warak region, that is the Assam, Northeast India. So this work is actually mainly discussed mainly the service life and the deterioration and the hazards, that is multi-hazards, of course. One of my PhD scholar is working on this topic, and it is under in progress. With this, I would like to move further. So in this topic, I will mainly discuss there are three things. One is say service life of the structures, and deterioration and the hazards. So like service, first of all, question may arise like service life. So we all see that not only even our engineering structures, we are considering their service, that is a design life. So that is actually service life basically mean the structure which has been designed, that is the to function satisfactorily, fulfilling the all the design criteria. Say for normal structures, it is normally we design for 50 years. For some moderately important structure, that is say 100 years, 500 years for highly important structures, as well as 1,000 years also we can go for say nuclear power plants and all. So these are actually being considered in the service life. Now in the service life also this is equally related actually to the like even our human, as a human being also we have some say lifespan similarly. So like the 70, 75 years, or even say that might vary. So but basic in the background actually, when we like our start our journey, that is life, in terms of structures, in terms of say a human being or a life living body. So in everybody actually in the background, actually as background work is actually say deterioration or say degradation. That actually process is also being initiated or triggered, that counting initiates. So this is the natural law. So now you like whether you do anything or not, but this process will continue, and you will this system or the in an integrated form, your components like will be degraded. So that process is a natural law, where we are discussing, we'll be discussing also in terms of our civil infrastructures. Mainly I am focusing on the bridges actually. So so this process will continue on natural basis. So this is one aspect. Another is as there is a deterioration, service life deterioration. Another is hazards. Hazards is actually just like your say seismic hazard, your say wind load, say cyclone, tornado. So like that, all kinds of say events, natural calamities or events, these are actually being triggered by various forms, and the structures or the system need to respond. So this actually now in this topic, mainly my focus is to like to show how if more say multi hazards, like say deterioration is happening of the structure, as well as say a seismic hazard or earthquake or flood hazards. So anything, suppose it is being encountered as an exposure, so how the structure is like its service life is getting degraded. So now this is a very common thing how we can see. So now my outline of this presentation is actually now going to be like background and the review status and the objectives, methodology and discussion, and conclusions. So now coming to this again, the discussion with this this is a very common and very standard term, that is a bathtub curve. So model which we are using to describe the phenomenon, that is a that is hazard rate, how it is changing with respect to the time or ages of the structures. So these are basically divided into three phases, main categories. One is say infancy or the mortality phase, and say constant failure rate phase, or random failure phase, and another is a wear out or say deterioration. So that three phases whole like in during that whole design life or the service life, the structure will undergo on all these three processes, and its hazard rate will vary according to the requirements or the encounter or exposed by the condition and like environmental condition. So now in the first phase, early failure is very common. Here as a this even say it can be considered with some like our civil structures, like that will be immediately during the construction there may be a failure, more likely that structure is going to be failed. That chances will be occurring more commonly and early, that is called early failure. And in the middle, actually in the design life, actually we are considering in the middle phase, that is a random failure. In this case, all kinds of events like your earthquake, if it happens, if it is a say 50 years is being designed, so in between, suppose in this middle phase or the random failure phase or constant failure phase, that hazard is constant, because anytime even immediately entering in the second phase, a structure can fail anytime. So it is independent of say time or ages, so it may fail due to the exposure condition encountered by the structures. Similarly, so that is the middle phase. Third phase is a wear out or the like a deterioration, which is a natural degradation process. Like like our human body is also satisfying these three conditions. Say after 60 we become a senior citizen kind of, so thereafter our some components of the body may be deteriorated. So and this is happening, and this is the natural laws. So similarly for structures also, like as we discussed, so this process initiates and accelerates at the third phases. So this process is a true or common for any kind of earth mechanism. So whether it is a living or non-living body, so all cases this is equally applicable. Now in this case, like how to design for a structure for such load for such kind of exposure, like which is encountered during the design period. That is that we normally, this is the load combination you can see in various codes. So as well as the like total load, dead load, live load, and the earthquake load. And also as we assume that in this ranges dynamic loads, which is earthquake or maybe wind load, if it may occur either earthquake, both simultaneously, we are not considering in the design. So any one will occur as a dynamic force or the say random or stochastic manner, and you have to like estimate the load that is in the worst scenario that can be experienced by the structures. So we are actually considering. So in this case, we consider mainly like your like how, at what frequency, like FT in a SDF system, you can see single degree of freedom system, FT, which is a say F sine or say omega or PT suppose. So in this case, at what frequency that excitation force is being experienced by these structures. And with respect to the amplitude, so that the excitation or the say force that need to be quantified. So it may be wind or earthquake, whatever load. So we have to bring down bring it in the design process, and we have to analyze. So that is the process. So now here, so this is actually the say in this study what we have used is these two, earthquake and then natural say deterioration process. So these are the steps actually we have followed, that is called condition assessment, say process we have followed here. So condition assessment, if we say what is the current status of these structures, including like globally, including its various components. So in this case, condition assessment mainly there are various techniques to evaluate the condition of the structures. Here, like we have used the that is called like NBIS, that is a national breeze inventory system, which is adopted in USA, Canada, so for their breach inspection purpose. So that actually in this study we have took that idea and we have implemented for the Barak Valley Assam region using the visual inspection. So this breeze inspection actually now connected, if you see, and for that inspection purpose, you can see various engineers are involved. That is called bridge engineers, and they are day by day on even monthly basis. So they are reporting the status of the structural condition, and it is being recorded, and those data or information is being used for this monitoring system. Even India also took the initiatives into I think 2 or 3 years back. So that is a called Indian Bridge Management System. So for bridge health monitoring system. So this is a very easiest and the preliminary kind of like our in say RBS kind of techniques that we used for to quantify how much like damage being on visual mode. So and there are various methods for that. NDT is one of them. So we can adopt it so to evaluate this current residual strength of these structures. So so these are the condition assessment here, just like there is a visual inspection technique that and also like not necessarily in a flowchart form, it is being shown over here. The data has been utilized for estimating the the differences, and these are some of the statistical methods like the people are using for the data that has been obtained from the field in situ monitoring that is data. So probabilistic and deterministic both we can we can use for assessing for the residual strength of the structure. That is our main target, because so that we can estimate the what is the exact or the current strength of the structure is having for delivering the or discharging the functions. So some of the literature review, although it is not at this stage, I shown over here, like various people have studied throughout the globe, and they have reported in various methods, as well as the in very experimentally, as well as in analytically also. So so these are the review status. Finally, we can say here like what are the summaries actually is being coming out. One thing is considering the Indian context, like here, Oregon, Florida, Pennsylvania, so like Washington. So all these places they have used actually successfully this method are like updated and categorized their bridges as per the that is called like using there some rating that they have used. I will show that. So say 1 to 9 some rating they have used, and description is there for each rating, how to quantify. And so this is actually another is a inspection interval actually that is helpful to estimate at what interval, like there is for say annual maintenance, budgetary maintenance already for the existing bridges we require. So for that case, they have actually reported that like a 24 months to 72 months are the appropriate ranges, minimum to maximum for the inspection interval of the various bridges for monitoring. So that helps to fix up the budgets for maintenance purpose of the service bridges. So as for guideline is there, so NBS, so they have used. So but in our Indian case, very limited this kind of say study not like being actually implemented, but it has been planned. So hopefully it will be implemented gradually, which is very important for the safety of the bridges as well as the say traffic various traffic conditions moving on the various important locations throughout the country. So this is very that will give the safety and the serviceability as well as the economy. So all on a like appropriate basis. So if we adopt that technique, so that was the study like we have adopted for our study area. So so these are actually various methods also can be used, including fuzzy and probabilistic. So and also the like so their say deterioration rate mainly we want to estimate in terms of aging, corrosion, and the load. So all these need to be evaluated properly, and that will help for our study requirements. So now in this study, actually there may be so many study can be conducted based on the fixing the objectives. So but here like condition assessment, what we have done here using we have followed the NBS system, that condition assessment of these RC bridges we have adopted, because RC bridges are number of their number of like frequency of these bridges are in a much more compared to say wooden bridges, steel bridges, pre-stressed bridges. So RC bridges are very common in terms of national highway and the state highway bridges. So that we have considered for the three districts in the Assam. So and their combined effect, as also you know that Northeast is seismically active 6th position throughout the globe. So this is also a very one aspect that has been considered. So aging and the earthquake both have been combined in the study. So this is the study area actually in our area. So this is a like 3 districts we have considered, and this is a Google map. So and this is the seismic study that we have conducted already for identification for like faults and the other like seismic hazard finally in terms of say the various hazard curves and their responses especially. So this study we have conducted, and so and the methodology here like aging and earthquake hazard both are actually being considered side by side, and we have combined it in our mathematical model. So and why we have adopted the that is like visual inspection actually in this condition assessment, rating assessment. So because it is very easier and low cost involvement is there and less equipment is required at the preliminary stage. So and the primary method like I used dominantly and not related to loading based study here. So if it is a detailed study if you want to do so, then we can like go through for say NDT using NDT techniques, and we can assess the what is the residual strength. So this is for this reason we have used this method and physically inspected various bridges. Around 150 bridges we have inspected, and this study has been done. And if you see here, so like visual inspection, that like what are the like characteristics like cracking and expansion in the like joints problem will be observing like and scaling, erosion, corrosion, and various components mainly in the joints. You will see these kind of problems frequently occurring, and various types of say the damages in superstructures also like human hazards, increase of traffic problems, so vehicular accidents, and so all these are actually encountered by these in service bridges. So these are some of the typical pattern actually like shown over here, like which we have inspected and collected the various like conditions actually like the crack pattern and all. So these are some of the typical representation for the various inspected bridges in our locality or the districts. So these are the things. And now, if you see over here, these are the condition rating that has been described or given in the NBIS guideline. So that we have followed, and description is given what type of failure will be coming given or assigned this rating and all. So that we have adopted, and these are some of the bridge rating condition. Finally, we found that is a CR condition rating 8, 6, 7, 5. And which one is higher? There is a condition rating 7 is much higher. So, and we have also classified like national highway route and the rural routes. So and their rating 9, 8, 7, 6, 5. So we have classified, and this is the just a distribution of the various in like that is a routing that is available in the district. So, and this is the method actually that we have adopted for modeling purpose, that is a viable distribution, and statistically, and that is for deterioration modeling purpose. And we have combined the earthquake
Dr. Seal, sorry for interruption.
Yeah.
Kindly conclude in 2 minutes, okay, because we are running behind the time.
Okay. Yes. Okay. So this is actually the hazard curve, seismic hazard we have conducted, and this is a PGA special variation for this area. And this is the seismic frequency hazard rate, seismic hazard rate for various magnitude ranges we have collected. These are available in our paper also. So, and these are the faults which are responsible for generating high seismic hazard for this study area. And this is the actually important part here, how service life is being reduced when combined like earthquake as well as the deterioration is happening. So it is actually the showing the how much this is the without degradation, and this is after happening this earthquake. So this is the reducing the design life. So if we see, and this is also the rate hazard we have represented over here, and this is the how much aging effect and the combined effect. So it is reduced. It can say 17 years is the aging rate, and it can come down to 9 years if earthquake happen with a magnitude of 5 and above. So like that, we have estimated for the respective frequencies. So this is the conclusion that how service life actually is influenced on this service if both the events are actually being affected together, service life comes down, and which is very important. We need to consider in our study instead of taking the single steps. So yeah, thank you. Then question.
Thank you, Dr. Seal. So thank you for your wonderful presentation. You have touched various aspects like all the theory and the practically. You have explained the things how to assess, how to do the assessment of the RCC bridge, like considering aging factor also and earthquake hazard also. So thank you for your presentation. So I will take some of the questions from the chat box. So quickly. So the first question is from the Kamlesh Kumar. So NE is seismic zone 5. Northeast is, I think Northeast is seismic zone 5. So future bridge piles should withstand higher than .36 G, 0.36 G.
0.36 G,
may be close to 0.5 G. So can you tell something about this one?
He is talking about the seismic hazard. Yes, it can. Yeah, if it is a zone 5.36 G as per the codal provision is mentioned, but that's why site specific study, because if you know that, why we are revising question that need to be understand. Like why we are codes we are revising on a decade manner. Actually, some say earthquake has occurred. Say Bhuja earthquake occurred. So in 2001. So thereafter the code has been revised because hidden faults that may be actually like tectonic setting actually changes after a big earthquake. So in that case, your whatever seismicity you have estimated before that big earthquake happened in that particular selected area. So your as your seismic setting changes, like in the plate, so your status is changing. So that's why it may go instead of 0.36, it may go 0.5 also. So it is not a wonder, but that will happen. So what we need to do is we have to update our code and regularly on an like a decades manner, or even a yearly basis. Also some kinds of events which are frequently occurring. So that is that can happen. 0.5
Okay,
also
okay.
you can consider instead of 0.6.
Thank you very much. Probably the last question I will take from Arjun he's asking about during the bridge inspection, have you ever seen the measuring signal is perturbated with respect to the length of the wire and time of the measurement and the temperature?
No, temperature, yeah. So see, here it is a visual inspection that based on the guideline, whatever in NBS is being mentioned. So we have followed that rating that say 1 to 9, and we have followed that and quantify that rating based on the found like in situ condition. And other thing, we may go for some vulnerable structures. We can go for detailed study. So that is not done, but we have in this case only NBS guideline we have followed for our this study purpose.
Okay, thank you very much, Dr. Seal, for your nice
detailed study can be or site location or bridge specific study can be conducted in detail.
Yeah. So thank you very much, Dr. Seal. So because we have the shortage of the time, so you can contact Dr. Seal directly. He will explain all your query. So with further without further delay, we have to move to the other important lecture, which will be delivered by Professor Darren Sian. So let me briefly introduce Professor Darren. So he has obtained his PhD at Cambridge University. His contribution in earthquake engineering lies in the field of the catastrophe modeling, landslides, and damage vulnerability of the underground structure. He was funded by the UK Engineering and Physical Sciences Research Council as the geotechnical specialist to carry out the reconnaissance missions in several earthquake events. Since 2009, Professor Sian was named top 10 innovators under 35 in Asia by MIT Technology Review for his Nobel contribution in catastrophic modeling in 2016. So he is also an IRDR Young Scientist under the United Nations Office for Disaster Risk Reduction. So with this brief introduction, I would like to request Dr. Sian to continue with his presentation. So floor is over to you, Professor Sian. Yeah.
Hello, hi. Can you hi, can you hear me? Can you see?
Yeah, it is fine. Yeah.
The PowerPoint slides.
Yeah, slides is also visible. You can go ahead.
Okay,
Yeah.
so it's in full screen. Hi, can you see my screen?
Yeah, it is visible, Dr. Sian.
Okay.
Yeah, you can go ahead.
Right.
Yeah.
Hello, hi. Good morning. I'm Dr. Darren Sian from the National University of Singapore. It is a privilege to be speaking to you on the experiences I had during post-earthquake mission. The topic of my talk is on theories and observations during such reconnaissance. As academics and once a student myself, it is rare for us to challenge what we read from textbook. The theories we learned We take it that they are correct. We take it that it comes naturally as knowledge to us. However, behind every series, there are hard work and sacrifices. On the other hand, there are assumptions behind these theories which make research a never-ending journey. In this talk, I will not be challenging any theories. Instead, I will share what I've observed in past earthquake missions and link them to theories of earthquake engineering. So this is the flow of my presentation before I wrap up with a conclusion. Earthquake remains one of the most destructive natural phenomena to date, and it leads to extensive damage to buildings and lifelines. Ground motion is dependent on the characteristic of the earthquake source, as well as the medium which earthquake wave travels in to reach to us and our infrastructure. The ground motion features consist of amplitude, frequency, content, duration of shaking. I would also like to stress on the structural features, especially the reinforcement, as well as the construction sequence, which could have an impact to the outcome following a major earthquake. Before I discuss about my observations in past earthquake missions, I will first wish to express my heartfelt thanks to IFIT. IFIT is the Earthquake Engineering Field Investigation Team, operating under the auspices of the UK's Institute of Structural Engineers, which is a group of earthquake engineers, architects, and academics who collaborate with colleagues in earthquake-prone countries to improve the seismic resilience of traditional and engineered structures. It was formed in 1982 with a joint venture between industry and universities. IFIT's main purpose is to conduct field investigations following major earthquakes and publish findings to the engineering community via the issue of free-for-all comprehensive reconnaissance report, as what that you can see from the link here. So if you were to go to this link, you'll be able to see a wide range of publications which IFIT has produced. You can use them as reference, be it for your research or for information purposes. In this talk, I'll be drawing inspiration from 3 earthquake events which I was part of the team. They are the 2009 Padang Earthquake, 2011 Toku Earthquake, and the 2016 Multi Earthquake. Now we move on to the body of my talk. Okay, as I said earlier, that the ground motion characteristic consists of amplitude, frequency, and the duration. I will now throw a quick question to the audience. Which building do you feel that you would suffer the most damage? Is it the short, the medium, or the tall building? Okay, since it's a virtual talk, so I'll just move on. Okay, just keep the answers in your mind. Okay, and we will move on. Okay, so let me show you this video clip that I got it from YouTube. Okay, so we have 3 buildings which is sitting on this shaking table, and what we are doing is that we are slowly increasing the frequency of this shaking table. And let me fast forward, and you will see that the tall building is shaking violently, while the medium and the short building is not shaking as much, right? However, as you increase the frequency higher and higher, then you realize that the tall building stops shaking. Okay, instead, you have the medium building which is shaking a lot. Okay, and if you were to increase the frequency even further, then the tall and the medium building stop shaking, and it is the short building which is shaking violently, right? So from the video clips, we are now able to appreciate that different buildings will respond to shaking very differently, right? When the shaking coincides with the building's natural frequency, the building shakes the most violently, and this is what we call as resonance. The taller the building, the lower the natural frequency, and the higher the natural period, which is a reciprocal of frequency. A 2-story building would have a natural frequency of about 5 Hertz or 0.2 second period. A 20-story building would have a natural frequency of about half a Hertz or 2 seconds of period. The first earthquake that I would like to introduce is the Padang earthquake. And following the earthquake, a total of 380,000 buildings and more than 1,000 casualties were resulted. As illustrated above is the earthquake intensity as indicated in this Roman digit here. Okay, the nearer is to the epicenter, the higher generally is this intensity, which is what we call as the modified Mercalli index. Okay. And this slide shows the earthquake spectra of the earthquake. Okay, as you can see, the dominant frequency as indicated with high peaks, okay, of the acceleration are within the range of 2 to 5 Hertz. And this range of frequency is expected to affect 2 to 5 stories building most significantly. This slide shows you the performance of unreinforced masonry structures, and as you can see, they perform poorly as usual. Okay, in many of the earthquakes, they don't perform very well. And similarly for wooden and non-engineered structures, whereby I can see a total collapse of buildings in severe cases. And I'm going to give you an example from this elementary school that we have visited in the field. There are several aspects of deficiency in the building design. Okay, first and foremost, we can see that there's poor connection between the walls. There is actually no reinforcement type across the two sections of the wall, which is, I mean, we're basically asking for trouble. And also, this slender member here is in fact one of the columns of this building, and you can see that there's insufficient reinforcement. That the column is way too slender as well. And furthermore, as you can see from the failure of this entire wall, it is actually delaminating from the ground, and you can clearly see that there is issue with the foundation design as well. The embedment of this wall and the foundation is probably not deep enough, to provide that, that confinement, and hence, therefore, when the walls start moving upward, okay, the roof collapses into the structure itself, which is pretty scary, in fact. So next, we look at a medical center which was affected by the earthquake. We observe round, smooth reinforcement bars with large confining reinforcement spacing, okay, used in those buildings as well as for this this medical center as well. As a result of this smooth rather than rigged rebars, the bonding between the steel and the concrete would not be ideal. Okay. Secondly, the confining reinforcement should be placed at close intervals so as to provide that confinement to hold the structural member in place rather than allowing it to buckle and to fail here. Now we look into the various engineering buildings which have also suffered poorly during the earthquake. First, we look at this hotel which failed catastrophically with 140 people trapped. 8 were alive because following the earthquake, following this collapse, these 8 people were still sending SMS texts to their loved ones. They were still alive in the collapsed building. However, search and rescue teams were too late in getting them out on time, and hence, therefore, none of them were being rescued, which is a very sad thing, which is a pity. Next, we look at the soft story collapse of another hotel, and as you can see that the ground floor is no longer there. Okay. In addition, we can also see plastic hinging at the column ends as well. I've prepared a small cartoon here to illustrate how the building could have failed. Okay, so we can clearly see that that we have a rigid beam, so to speak, and we have slender columns, as you can see over here. Okay, so this is the cartoon that I'm trying to illustrate here. Okay, and when the earthquake starts shaking, the hinging starts to develop, and eventually the first story columns start to give way, and eventually the ground floor is sandwiched. Okay, and this is what we typically call as soft story collapse, and it's often happening at the ground floor because that is that's the floor whereby it is carrying the upper floors loading all the way to this ground floor columns. And we have also seen many other buildings in Padang which has also suffered similar soft story collapse. As you can see here, the ground floor is no more. Okay. Similarly, that you can see that you have a very stiff upper floor, and most likely that the ground floor were supported by slender columns. And similarly for the example on the right hand side. So this is yet another example of a collapse of a hotel due to the lack of confining reinforcements at the beam column connection. And this is myself near a government building which had suffered from soft story collapse. This portion of the beam should be horizontal. However, because of the loss of the ground floor, and hence therefore the beam is being dragged downwards. And you can see over here that this is the remains of the ground floor column. Okay, and come to think about it, in fact, it was actually quite risky to be standing there at that point in time. Okay, so again, we can see another example here whereby we have a stiff upper structure being supported by slender columns here. This is a total collapse whereby all of the floors have actually collapsed, and this demonstrates the severity of the shaking caused by the earthquake back in 2009. And from the photos, from the examples just now that I've shown, the highly damaged buildings were mainly 2 to 5 stories building, which coincides with the natural frequency of shaking and the building itself. In contrast, we did observe high-rise residential and retail buildings which did not suffer as significant damage. In this building, despite seeing some of these cracks, these were actually on structural fittings of the building. The structural frame of the building still remains intact. It's still deemed to be relatively safe from the structural perspective. And you can clearly see that high-rise buildings, which is beyond 5 stories high, did perform relatively well in this earthquake. And that is also another evidence to show that that resonance is an important factor in our earthquake design. And also this is a retail building whereby you can see glass panels at the bottom here. None of it was shattered, and that is again another evidence that that the natural frequency of this building may not have coincided with the ground motion. Now I'm going to move on to the next earthquake, the 2011 Toku earthquake and tsunami. Okay, and as you can see here that the earthquake caused a huge ground motion of duration more than 2 minutes with PGA up to 2 G and more than 1 G for many other locations. And this slide shows the frequency content of the earthquake at various locations along the northeastern coast of Honshu, which is the main island of Japan. With closer look, you can observe that there was no significant long periods in the Toku earthquake. Okay, with taking typically between 0.1 to 0.3 seconds, as you can see here, the peak here, and that is for the Toku earthquake. And in contrast with the mid-Niigata and the famous Kobe earthquake, you can see that the peaks were all along the higher vibration period. And this explains why structural damage was not as extensive as during the Kobe and the mid-Niigata earthquakes. Okay, and this slide shows you the performance of wooden buildings, which I can see that it doesn't perform well. For this high-rise residential building, we believe that this, due to the height of the building, okay, and hence therefore the natural frequency of the building did not coincide with the violent shaking peaks. Okay, however, this building still suffer some shear cracks along the wall, as well as ground settlements, as you can see over here. Supposedly, the block on the left-hand side and the right-hand side is being connected by the corridors. However, right now, the corridors is being separated. The two blocks were being separated because the right-hand side building has suffered from ground settlement, and now the building is, from a one single building, okay, one single joint building to become two separate buildings now. Okay, so and due to this, the building was deemed to be unsafe following the earthquake. We can also see on the left-hand side another relatively old building, okay, that had also suffered, shear cracks along the wall of the building. Okay, and in contrast to the new building, which is seen at the center of this slide, whereby there was no visible damage. Okay, and this is attributed to the different versions of seismic code that was being used at that point of construction. Okay, and I'll discuss this more in detail later on. On the right-hand side, we have a two-story building which had suffered from soft-story collapse. Again, such a low-rise building is susceptible to resonance, and hence, therefore, it is more likely to suffer damage as compared to the high-rise buildings in Sentai. Again, I can see that there's some deficiency with respect to the steel reinforcements that has resulted in the building more likely to fail. And based on these observations, that we can see that the damage was not as significant for the high-rise buildings, and this is due to the non-coincidence of frequencies between the ground and the building. I know that time is running short for me, so I'm going to rush through the remaining slides. Okay, and also that buildings which were constructed before the major seismic code revision in Japan back in 1981, they are more susceptible to damage, as we have observed during the 2011 earthquake. Similarly, over here that we can see that see the buckling as well as shear of columns due to insufficient confining reinforcements due to the old building code implementation. Okay, and lastly, on the Mutiny earthquake, okay, in 2016, again we can observe coinciding extent of damage, which is the y-axis versus the periods. Okay, and you can see that at the points of resonance also lies where the extensive damage were located. Okay, based on the building height to estimate the frequency of those buildings. So at Padang, we observed a 1.4 G shaking for almost a minute, and you can see buildings being damaged quite extensively. And this building, a 5-story building, coincides pretty well with this peak, okay, of resonance. Next, we look at another city at Porto Viejo, and 4-story buildings had collapsed, and it's coinciding with this green peak over here, okay, and similarly, it is another evidence of resonance failure. So next, we look at the city of Manta. Manta is the one in blue color, and similarly that we can see failures, and do take note that the soft story collapse occur at the 3rd floor, okay, which we will dwell more in detail later on. Okay, and we have also observed several damage to the columns, and those were attributed to inadequate attention to the reinforcement design itself. Okay, and also we have also seen insufficient poor anchorage of links in severely damaged columns in other buildings as well. Next, I would like to share my thoughts on construction practices in some parts of the world, not only in Ecuador. It is understandable that building owners have limited funds, and they may like to extend their building even higher with more floors when they have accumulated more money over time. However, there are some consequences to such construction practices. So one example is the soft story collapse at the upper floors, as what that you can see on the picture on the right-hand side, the 3rd floor soft story collapse. And on the left-hand side, you can see protruding steel bars, which were lying there for the purpose of future extension of the building upwards. Okay, and it has, okay, and the pictures on the left and right also do show.
Excuse me, sorry for interruption,
sure.
Professor Sian.
Okay.
So please conclude because yeah.
Okay, this is my second last slide. The next slide will be the conclusion. You can see the reinforcements sticking out at the top of well-constructed buildings, and because of the fact that if you are going to extend the buildings in future, the joints between the old and the new members are typically being executed with insufficient lappings of the rebars, and that can actually cause a weak and brittle connection. And the reinforcements would also be lapped, okay, at the same height where the extension commences, and that also leads to the weakness at that extension floor. And if the building owner back then had failed to anticipate the increase in axial loading at the top, as you extend the building, then the building may be under-designed, and we are asking for a failure, if there's going to be a major earthquake. So those are the considerations needed for those owners who are looking into extending their buildings in the future to such a practice continue. So to conclude, we can clearly see theories do match with observations. Structural resonance remains to be one of the leading factors, okay, causing heavy damage to buildings, and insufficient poor reinforcement detailings were also being observed in all the 3 earthquakes, which we need to pay more attention to, and also taking note of the revisions of building codes, and how are we going to deal with buildings that were being constructed with earlier seismic building codes, which may not be adequate enough for future strong earthquakes to come. So this is the end of my presentations. I would like to acknowledge the joint contribution with my other team members of the reconnaissance team of the 3 earthquakes. I would also like to thank EPRSRC from the UK, as well as ISRE for the funding, and not forgetting also the support staff of EFIT at the background. Their assistance were greatly appreciated. Thank you so much.
Yeah. Thank you very much, Professor Sian, for your very informative lecture. You have touched the various aspects like theory, observation, as well as practical aspect to be required, like for post-earthquake recognition. Okay. So I will take one or two questions if time permits. So one question is from Tham. So he is asking about, do you agree with me? Earthquake not only create inertia force in lateral direction, but vertical direction as well.
Yes, this is a very good question. In fact, we have always been looking at horizontal shaking of the earthquake. However, the vertical impact can also be very significant. In fact, it can be even much more significant because that would, in fact, cause more axial loadings to the columns. And if you were to imagine that if the columns is susceptible to soft story collapse, and if you have this pounding effect due to the vertical direction of the earthquake shaking, then it will actually cause the columns to fail even much more easily. So yes, so this question is very valid, and I do thank.
Thank you very much, Professor, for your response. So actually we are running behind the time. So I would like to request all the audience, if you have any query, you can contact to the organizer, or you can directly contact Professor Sian for if you have any questions. Okay.
Thank you so much.
Later also. Okay. So thank you very much. So without any further delay, we'll have to move to the third important lecture, which will be delivered by Dr. G.R. Reddy. Okay, so Dr. G.R. Reddy is a senior professor at Homi Bhabha National Institute, teacher for PhD in University of Mumbai, and outstanding scientist at Bhabha Atomic Research Center, Mumbai. His research expertise in the area of structural dynamics and earthquake engineering. He has contributed in developing simple numerical modeling techniques for complex structure equipment interaction due to earthquake, stochastic method of analysis, dynamics of structuring technique, and etc. He was involved in developing seismic hazard at various sites of nuclear facilities. He has mastered seismic response control method and developed passive response control device, including seismic based isolator, which will eliminate snubber in nuclear facility and reduce the initial cost, maintenance cost, and improve the safety. He was involved in developing methodology for seismic margins assessment in piping system and structure. In addition, he contributed in the design of 30-meter antenna for the Chandrayaan project and of a large-scale gamma-ray telescope. He has regularly given lectures on the vibration and earthquake engineering in Training School of Department of Atomic Energy, involved in IS and Departmental Seismic Code Committee. He guided large number of MTech and PhD students and has authored more than 500 research publications. So with this, I'd like to request Professor Dr. G.R. Reddy to continue with his presentation. Over to you, sir.
Hearing me?
Please.
Yeah. Thank you so much. I hope you are hearing me.
Yeah, it's fine, sir.
I'd like to share my presentation. So all of you able to see my PPT, please?
We are able to see.
So thanks for Mr. Arvind K. Jha for introducing me, but there are some corrections in the introduction. Presently, I'm not in the Bhabha Atomic Research Center. After my contract, I can say that, till 60 years is completed. Presently, I'm a adjunct professor in NIT Surathkal, and NIT Surathkal as well as VGTI Mumbai, plus as some social activity as a president of Association of Structural Rehabilitation and Retrofitting. So small correction on my introduction. Yes, and still I seriously continuing on my research related to the safety of structures, systems, and components. So with the small corrections, let me proceed on my topic on structural rehabilitation and retrofitting for risk reduction. So this particular topic is very, very important. Also is a good coincidence that earlier speaker, Dr. Chain, talked about the, various, performance levels of structures subject to the actual earthquakes, and what are the causes, many things. So that particular topic is definitely a good continuation to my, lecture, what I'm going to talk on the structural rehabilitation retrofitting. Kindly, I just to make a few limitations. My talk will be more on philosophical aspects. I guess I will be talking something on more technical, some kind of equations, but not too much on that front, but more philosophical aspects to have the preparedness, to have less risk, during any, say, accidents or any events of disasters. Now, risk, this is one you have to keep in mind when throughout my lecture. Risk is going to in the hazard, then you have the vulnerability and exposure of structures. Now, this particular conference is focused on the civil engineering structures. Therefore, this particular basic relation of the risk with respect to the structural vulnerability and the exposure of the structures, apart from the hazard, is very important to keep in mind while this lecture is going on. Now, hazard, I think many people talked. I could attend few, presentation talks in this particular conference. Like Dr. Rastogi talked about hazards, particular earthquake hazards. Little bit on floods also. Not he, but other speakers have spoken about it. So we are not going to talk much about the hazards, because we assume in sense we are definitely going to have a lot of hazards like flood hazards. Then you have seismic hazards, you have the blast hazards, many hazards going to be there. You have to get prepared and ever ready to have the less risk in terms of the economy and life of the people. So that's what, and also before, also let me, before starting my lecture, let me also say thanks to the Dr. Srivalsa and the group for for inviting me to present this talk in this conference. So let us recollect a few, inaugural function time lectures, like Dr. Bhandari mentioned about, I think some kind of, okay. Dr. Bhandari mentioned, there are generally the bridge failures are very common during the, hazards like floods and earthquakes. He also mentioned the cry of nature. I think, yes, he must have used that word, but I feel it is better to maybe, in my context, it is better to say that the abnormality is like a mother suffering from fever, then indicating the children to say, take care, when I am not in good condition, you should take care of yourself. So that way, if you think about it, so there are going to be some abnormalities in the, say, behavior of the nature, particularly earth, in terms of the, say, flooding and in terms of the earthquakes. So we have to get prepared for that. And also, when you talk about, you just listen to the, if you have carefully watched on the Dr. Amar Tunga's, points, what he mentioned, the disaster, the whatever risk involved is mostly focused on the, say, structures. Maybe she must have talked that this is particular conference is with respect to the civil engineering. Nevertheless, it is definitely the structures going to be the maximum contributor for the risk in terms of the life and the economy of the countries where you have this kind of disasters. There's no doubt about it, because you are with the structures, you have to live with the structures, all the people, starting from your residence to the office, to the schools, temples, everything is considered as a structure. So if I want to have the low risk, the structures has to be in a good shape, and you have to ensure that apart from your own health, you also ensure the structures where you are going to work, where you're going to live, also be safe and healthy all the time. So that context, this rehabilitation retrofitting will help, and finally it is going to have the less risk. That's what I'm going to talk more on that. Now we have to get prepared. This is some of the points what Dr. Amar Tunga has mentioned. And also, if you try to recollect, I just want to make a link between the requirements of rehabilitation retrofitting of the structures with the talks already delivered, or basically what I attended. Dr. Manisha mentioned about the floods and the contributors of the structures in the case of dams, bridges, how really had a lot of risk during the recent floods in Kerala. A little bit, I know my general ideas about that. If you want to reduce the flood risk, what are the things can be thought for the whole country? I just few slides I will talk about that. Then the green infrastructure, so they are all interrelated. The floods, the kind of rain catchment, then the structures all are related to each other. So the Christoph has also talked about green infrastructure, considering the Edinburgh city. So this all, if you want to have a less risk, if you work together, then you can have a better, life with less risk. That's what I want to just focus and tell about it. So see here that, I do not know this particular things can go aside. Okay. Yeah. So you can see that, the floods point of view, we'll just talk about floods point of view. See, you have, say, Brahmaputra to Mahanandi. It is in the Mahanadi in the Orissa. Then you have Godavari in Andhra Pradesh, Krishna in Andhra Pradesh, and that touches many states of India. You can also see the rainfall. It's in the western part you have a huge amount of rainfall. Even say northeast part you have a huge amount of rainfall. Definitely, good amount of rainfall is received by the country. And the important thing is you can see naturally the whole country is connected, well connected with the natural canals. Now, the point is that when you want to have the flood risk, you want to reduce the flood risk, then what you do, you should utilize the naturally given gifts like this, various channels of connecting the, various places where flood prone. For example, whatever examples she mentioned in the Kerala. And, in floods also, is possible when the, like, for example, Bombay also seen some amount of the floods when you had recently about, I think if I remember 2005, a sudden with a short duration about 900 rainfall, you had a big problem whole city. And that is also what I want to say, that kind of flood scenario is happening because of the contributors from ourselves. So some of the things we can reduce. If you try to avoid such kind of things, you can have the better, flood-free situations in the country. Now, I just, considering this kind of situation in the country, if you have some kind of blue revolution, one can think about it. Yes, you have the places where you have possibility of the flooding. Now, if you are able to catch this particular rainfall, and you just, see this kind of scenario what I made is, as an architecture, or is what's that called, some kind of hand sketch is made to have the overall idea. Wherever you have a good catchment and flood prone areas, you try to catch it, store it, and to try to transfer, like, she mentioned that, there are interlinking of rivers within the state, and but still the capacity of that particular, rivers, and at the end when it's trying to reach the sea, the levels have increased, because once the level of sea and whatever the storage levels, collective levels are in the same, then you cannot have the exit. So there is a possibility of flooding into that area. They have that kind of risk. So when you have stomach full, you also try to see that this kind of resources can be also transferred to the other part of the, say, country, other part of the state, other part of the district, you can transfer, so that you have a flood risk can be reduced. So how you can do that is, this is some of kind of bird eye view of thinking, what you can see here. When you have the catchment, make your reservoirs, particularly when you see this kind of studies, when I try to make with my friends, that, the catchment, whatever you have in the western part of the country, if you try to utilize, if you are able to catch the overall rainfall, then you can definitely put 1 foot of water in the whole country. That kind of rainfall is there. And today and tomorrow, you're going to have the big disaster with respect to the water is concerned. And per capita level of the water, what you have in our country is much less compared to the most of the part of the world. So one should be very careful, and you have to really, try to, take the resources very well and try to utilize those resources very well. So you try to catch that, then we can transfer through, I can say that, so the WLS water lifting systems with the solar power, then you can lift to the other part where you have the less water, and you also required a lot of demand of water. And these systems can be, you have reservoirs, try to store it, then lift it, or you can tunnel it and try to have the distribution of the water to the other side of the, not on the seaside, other side of the say, sea, and the catchment area will be well connected. Once you have connection with that, then you see that the flood levels definitely not going to be there. In addition to that, you are going to also meet the requirements of the demand of the water in the country. And other than additional benefits, what you are going to have, the groundwater level in the country, if I remember my childhood days, particularly 6 to 7 months in the rainy season and winter season, I used to take the bucket and pick up the water from the well. Today, I cannot think about that. The groundwater level has gone to, say, maybe 400 to 500 feet inside the ground. So water level in the ground is really depleted very, very badly. So that part also can be filled if you are having the well distribution of the water, whatever the God is given in terms of the rain in our country. So these various topics like, solar power, water lifting system can be made, feeding water to the ground. So then you can have a greenery can be developed. That's what other friend mentioned, green infrastructure. When you have, then things are much better. You can catch the rain also better. Then things will be self-sustained when you have this kind of distribution is there. Save environmental forests. Then river links can be made very nicely and they have the proper distribution. The production of food can increase very well. So then, sea life. So people will talk about the environment, save sea life. So whatever required, they definitely wanted to have the sweet water entry into the sea is definitely essential. So you can also maintain that kind of requirements. So maintain seawater links. Then you have the reservoirs and catch monsoons very well when you have this kind of distribution. Now, I just mentioned this is the thing we can do for most of the part of the country. Now, what I wanted to say that in order to have this, you have to make a lot of structures like this. You have dams, then you have check bunds. And recently, whatever the things happened in the sea, what is that north part, because of the glacier is melted down quickly. So you have the dams failure. In our country, you have the old dams, the life already maybe 50, 60 years life spent, major dams. So one should be, look into that, health of the structures and see that, they are going to, serve as for the intention of the particular dam, and see that, suppose there is a sudden failures, then you can think of, whatever the recent happened in the, north part of the country. Such situations happen, then you have more flood problems. So the structures plays very, very important role. Even if you have interlinking rivers, then you have the check dams or plenty of the check dams, and then you have to keep ensuring that the health of the structures are updated, and rehabilitation retrofitting is essential. We have to doing that in order to have the continuous service as intended in the design levels. So otherwise you can see certain kind of failures of the whatever links you are going to make the canals. I think this is the picture taken by whatever Vivek K. Kapadia, government of Gujarat. So thanks for utilizing. I would like to say thanks to him because I utilized his pictures. Otherwise, you have this kind of embankment failures, and you have to keep this life of these structures very well. Otherwise, if these are blocking the way of the flow of water, as I already mentioned in the invited talk, and then you will have the flooding problems, and you have the risk there. So structures, so slowly, I'm just trying to give the information, the importance of the structures. So another experience is there. When you talk about the villages in the olden days, we have a lot of lessons, but sometimes we forget in the, as the time passes, and we try to do small errors. I'm not telling, I kindly remember that I'm not putting any blame on anybody. It is my own understandings, and whatever the knowledge I gained, I want to share with all of you. That's the reason. So it is not, I'm not intending to point out anybody or any issues I want to raise, not that. Kindly remember that. Now, if you collect, because I'm from village place, the villages are well built. Generally, they are, built on the foot of the hill. Then also they try to catch the water, and they have some kind of earthen pond and the bunds, so that that water catch and reserve is also utilized in the winter and the summer seasons. And they never make the villages on the downstream generally. And also very importantly, the agricultural land never touched. So that is always they keep in mind. So this is the lessons coming first, maybe thousands of years. So we should not forget about that. Now, but today we are having some kind of thinking that, in the Delta area, we want to have the, say, in huge cities, you have the smart cities, and, you have the cities, say, when you build the cities, there is always a difficulty. Yes, definitely you can have the proper planning and maintenance. You can definitely don't disturb the environment. Possibility is there, but there is after all, we are human beings. There is some kind of negligence going to be there, because you will be more concentrating on the whatever current activities. So when people are forgetting 1977 floods in the, say, Krishna Basin, it was a huge flooding. I hope many people must be remembering. But still, we are thinking to develop big cities in the Delta area, that is agricultural land. And also we are going to have the, cities in the flood-prone areas. And later on, we say we have a flood risk. So that kind of thinking please to avoid and don't make the structures in that kind of situations. Now, another good example is the city, Mumbai city. It was naturally is of 7 islands. Today is a single island, right? Now, had that we kept as it is, yes, there is a lot of space around the city, the, inhabitation would have been there, other part of this particular islands, then things would have been much better. And today you have we have made the cities highly flood prone, particularly you have the huge amount of rains in the rainy season and highly flood prone city because of our plans and our preparedness, making the structures on the reclaimed lands, and we have made the city like this. Otherwise, it would have been very, very, very beautiful city in the country, in the world. So what I want to say that while making plans or while making the structure, one should be very careful in order to while developing the country. So all the natural levels are becoming drainages. So I can say that in Mumbai, in Chennai, in Hyderabad, even say Indore, we are seeing the clean city, but the river links, are becoming drainages. So one should be very careful because we neglect it. It's not that we cannot maintain it because the importance we shift to the other part. So we forget about this, but whenever heavy rains are there, floods are going to be there, the structures we don't maintain it, therefore they are not going to serve the intended function. Now, the disasters increasing, that's what Dr. Amartunga mentioned, it's doubling, maybe because of the, rupee values are changing, also your developments also going up, therefore your disaster increasing and the risks also increasing as the time passes. Now, all the contributors for this risk is, as she also mentioned, and we also noticed just now with a few projections that the risk is going to be, more around the structures. Now, the structures and also some mention made adaptivity, then redundancy, then resilience. These are some of the things you have to keep in mind in order to have better structures to reduce the risk during any eventualities. So a little bit introduction on that. Now, let us see these particular pictures. What we can see here, I think people are making in the structures, you have the evacuation centers, maybe because of fire problems. But people forgetting that when you try to make such kind of centers is good, definitely required, and they are going to be definitely useful. Even the COVID situations had we planned very well in advance. These all evacuation centers in each building, if you are able to have the possibility of making that local isolation, and that would have definitely reduced the spread of virus because people would have attended in that particular building, and local areas are kept in this particular isolated area and attended by the doctors with the proper what is that gadgets of the safety, etc. Then things would have been much better maybe than whatever you are seeing. So what I want to say, these evacuations are very, very important. But while making these centers, you can see they are making weak links in the structures. And these kinds of weak links, earlier days, I hope many people will be understanding, those are working in the structures, that soft story was the one very good concept when initially in the maybe 3 or 4 decades back. But today we cannot accept this kind of soft story design. But now this kind of so evacuation center making the weak links in the structures, you can see higher modes of excitation. Now, the previous lecture by Dr. Chain talks about different modes of vibration and different frequency components of excitation. So higher modes of excitations can try to excite the higher modes. That will be generated because the weak links in the say different story levels which we want to have as evacuation center. So one should not forget about that. If that is realized, then definitely the structures has to be rehabilitated and retrofitted to meet the design requirements, avoiding such kind of failure. So we can see, I'm not naming these buildings, but this kind of buildings are very common in the most of the metropolitan cities. So we can change the bylaws, to have this, evacuation center to be used even for the, disasters like, Corona-19, that COVID-19 situation. However, structures, when you talk about these weak links, it has to be avoided. And even today, I think if you understand that carefully, try to have the rehabilitation retrofitting and avoid the high order of modes of failure. Then, if you don't prepare, then you have the problems, definitely going to have a lot of risk during any, say, earthquakes or the high winds, even the blast waves. So this is, I'd like to share some of the things in how they are performed. So this is all platform I'm trying to generate some kind of what is the need, what is the importance of the rehabilitation retrofitting. This is one of the airports. It also becomes a lifelines of the structural components, structural systems in the country. So these are the, when I just was there one day before happening that Hudhud in the cyclone. And I was sitting just below this, but I could not catch because of cancellation of flights. Then I had to go by roads to some nearby place where I had some work. So this next day I could see this is the situation of this. So the wind, the high winds are going to definitely have the wind hazards. The cyclonic hazards are very large, and a classical example is the Tacoma Bridge failure because of wind loads. So the structures, when you try to see this kind of the cyclonic hazards, then you have to attend that the structures are designed properly and they are going to solve for the under the various hazards. And if not able to withstand, based on your assessment, then you have to go for the rehabilitation, retrofitting. Otherwise, all the lifelines you have a problem. Therefore, your risk in the terms of the life loss as well as the economy also going to be increased tremendously. So people always should keep watching the structures like your body, and update their health, and also improve the health by doing the proper rehabilitation, retrofitting. So these are some of the examples of the bridges collapse in the whole world. For example, the behavior of the bridges wherever you go in the world for a given earthquake, if it exceeds or the structural design is not proper and the construction quality is not good, maintenance is not good, this kind of failures are very common when the earthquake levels are of the design basis values of 0.2 G, 0.3 G to the 0.8 G, but failures are similar to the whatever you can see across the world. So on the right side, you have the picture of the Kobe, areas. In the left side, you have the Bhuj areas, but the acceleration levels are very small, but failures are going to be the similar kind. Apart from that, just one second. I have so this is another point, is that you have the this structures, bridges, and most of the world there are some kind of gaps in the design, particularly when you have the accidental loads generated because of the vehicle traffic on the pillars, and the road roughness because of the potholes and many other kinds of things, and there is a accidents on the road bridges itself. So they have a lot of loads can be generated on these dynamic loads, but these all not well defined in the design aspect. So one has to look into that. If those are not considered, because today the traffic levels and the demand on the bridges are becoming very high, and at the same time, these are going to be lifelines in the case of say in a disaster happening. So you have to keep updating your design philosophy, loads considered, hazards considered in the design. If not there, then you have to do proper rehabilitation, retrofitting to meet the whatever requirement. That's what I'm trying to explain in this figure. And you can see that various lifelines, so water, liquid, water supply systems, the bridges, even say temples, and as I also mentioned about schools and that's generally used as evacuation centers, hospitals. They also has to be come under the lifelines, has to be always keep understanding their health and try to update the structural capacities for meeting the any hazards going to be there in the future as per the postulations are there. Now, this is some kind of things I try to explain, that the failures in the world anyway on the lifelines or any structures are seen when you talk about the external hazards and their effects on the behavior of the structures. Now, coming to the recent, some kind of disasters apart from the earthquakes and the other things. Now, if you see say here, the industry, there was a explosions and a lot of poisonous gas spread. So there's big disaster locally in some part of the country. So this kind of failures when you have, because mainly we don't keep some kind of update the various postulations, whatever happening across the world. Second thing, the health of the structural component we generally neglect it in. That has to be, is not that many people are doing it, but there is always some kind of negligence as long as giving the services. But in this kind of, it's extreme situations, you are going to have such kind of failures, then you have the big amount of risk there. So these are the toppling of the cranes. So because of in the near Mumbai airports, and also because of health is not very good, and because of the heavy rains, and you see the condition of the bridges and the structures, even for the normal rainfalls, because of the aged structures cannot withstand the even small extra loads than its capacity. So what I want to say, that the structural capacity has to be revisited, understood, and updated as per the requirement. That's what I'm trying to tell from this. So whether it is a structure or it is a equipment or the industrial facilities, you have to keep watching all the time so that you can have the
Extremely sorry for interruption, Professor Reddy. So kindly try to conclude in 2 minutes.
Oh, it's already time is over.
Yeah, yeah.
Clock is to be there, no? That I could not see. Doesn't
Today actually clock is not there, so
okay,
yeah,
fine.
sorry for
That's
that.
good.
Yeah.
So these are the things I just introduction I try to make. So the adaptive technologies are the say base isolation that also talk. So a lot of things we can discuss, you can learn now from the nature and try to have that kind of features in the structure. Then you can have, for example, mangroves, then banana tree. You have the palm trees, how they are prepared for kind of disasters. Such kind of things goes into the say in the structural design, like base isolation is one of that concept used. And here I can see that recently I just saw the yesterday some kind of news when I tried to say the temples, thousands of years old temples, they adopted some kind of sandboxes concept too. And this definitely has seen the huge earthquake, Bhadrachalam earthquake, 1968 or 69, that also I experienced. So it could withstand without much problem, maybe because of this kind of features they built in the, while making this particular temple. So some kind of, the research we performed, I shown that they have a good adaptability, depends on the demand. It can behave very well. So you can see the, how as per the demand, they keep on shifting the time period to the enlarging the time periods, and your responses, inertia response reduces and is going to withstand huge earthquakes. That's what the adaptability can be developed in the design, structural design. So these are the lifelines. So it's starting from your house to the hospitals, and everything is the structures are related to each other. To have this, then we had put some efforts to have the guidelines on structural rehabilitation retrofitting under the umbrella of the Association of Structural Rehabilitation. We developed a good guidelines, and it's now available, and many people are utilizing that, and they are purchasing and trying to utilize the guidelines for health assessment, rehabilitation, and retrofitting of the structure. So various chapters are present in this particular book. Then so I just want to clarify on the repairs, rehabilitation, retrofitting. Repairs is just in the architectural aspect. Rehabilitation is to meet the requirements of design intents, and retrofitting is when the extra demands are postulated. You have to strengthen the structure. That's what we want to explain in terms of the retrofitting. The redundancy, flexibility, energy absorbing capabilities, and you can see the pictures very well that it is all related with the nature, starting from human life to the whatever the nature we have. Can be learn a lot of things and try to see, extrapolate, or try to utilize that knowledge with the structures, and we have this kind of what you call the adaptability and also flexibility. You have resilience in the structures can be developed. This kind of techniques can be adopted and improve the capacity of the structure. So if you talk about the mathematics, you have the static problems, normal loads, you have applied forces balanced with the resistance. In the case of dynamics, you have damping and inertia going to be there. And some question was asked earlier, the inertia has to be applied vertically or not. So inertia definitely going to be very important thing. And if you want to have a good structure for dynamics, so you should have less inertia. So less stiffness is good for, say, if you want to have long time periods. And also you have good energy dissipating capabilities, which can be understood from the basic spectrum of the harmonic loads as well as random loads. So conventionally, you have the increasing bracings, or putting the extra walls, or increasing the size of the structural elements. So you can meet the demands. In the case of say dynamics, you can try to have the other parameters of damping and inertia and the stiffness, try to have the sufficient strength to meet the whatever the extra demands coming because of the external events like earthquakes and floods. So this is what of some of the buildings we built for understanding the naturally how they are going to, this particular technologies are going to be useful. In IIT Guwahati, this has taught a lot of lessons, and we have data, I think, that's available in the whole world, in the country, where somebody want to validate their analysis and design tools with the base isolation. So you can use that, you can approach the IIT Guwahati to get the data, and you can utilize for your understanding on the base isolation. So I think so. This is all kinds of repair. I just focused on the say new techniques with respect to dynamics. You can use the base isolation, energy absorbers for rehabilitation, retrofitting other parts of the say health assessment and walkthroughs, and visual inspection as a part of the rehabilitation, retrofitting, all discussed in the guidelines. One can go through that. So I just want to say this particular last slide. When you want to have the risk reduction, so when you want to have the risk reduction, So this is the one kind of what you call the diagram which everybody interested into it. So when public life has to be saved and the economy has to be saved, the agencies like, for example, institute and research center, designers and consultant, utilities, and the disaster management authority has to work together and keep updating the understanding of the hazards and keep developing the technologies and behavioral characteristics of the structures and changing the design philosophies and keep updating the health of the structures and its capacities as per the new understandings, new design rules, and try to make the whatever the hazards going to have, so that you have the less risk in terms of the life as well as the economy. So with this, I just wanted to close it. And only last slide is that you should have all the structures: low inertia, high energy absorption, high redundancy, high bearing capacity, and this adaptability. You can see this mangroves, if you try to understand the growth, if is very interesting. So such kind of philosophy, if you are able to build in the structures, you are definitely going to be prepared for any hazards with low risk. So that's much I want to say, and thank you for hearing me. So any questions, please?
Yeah, thank you very much, Professor Reddy, for your excellent and actually it is very well articulated, informative presentation. So although we are running behind at time, so I will take one question from the chat box. What about the disadvantage of isolators? So can you comment on this one?
Yeah, see, I hope are you hearing me?
Yeah, we are.
See, disadvantages you can manage. For example, if it is a isolated building is independent, no issue at all. But you have like appendages like your fire water system, you have the water supply system, electric system. They are going to have a large deformation, but that can be easily managed by proper flexibility introducing in the appendages coming onto the structure. It's not a big problem at all. Yes.
Thank you very much for your comment, sir. And actually, we are unable to take other question, but I'll request I'll request organizer to pass the question to the speakers, and probably somehow he will respond and will get the answer of all these question, I think. So because we are running behind the time, so we'll have to go for the last presentation of this keynote session.
So thank you very much. Yeah, I'll just mute. Okay.
So this presentation will be delivered by Dr. Basant Raj Adhikari. So let me briefly introduce about Dr. Basant Raj Adhikari. Dr. Basant Raj Adhikari has a research interest on the tectonic of Himalaya, climate change, hill slope movement, and human interaction, Himalayan sediment flux generation, and disaster risk reduction. He has provided technical support in many development projects in Nepal, Himalaya to control the slope movement. He is the author of the several scientific paper, more than 40 scientific paper and the book chapters, and received various recognition for his work in the field of earth science. And that is a young science. He was also awarded with some awards like Young Scientist, Integrated Research on Disaster Risk, and Young Affiliates by the World Academy of Science. So with this brief introduction, I would like to request Dr. Dr. Adhikari to proceed with his presentation. So over to you, Dr. Adhikari. Yeah.
Thank you, Dr. Zai. Am I audible?
Yeah, you are audible. Yeah.
Okay, let me share my screen. Is it visible now?
Yeah, it is visible. Yeah.
So in full screen mode, right?
Yeah, it is okay. Yeah, it is fine. Yeah, you can go ahead. Thank you.
Thank you, Chair, and it's always here to listen Professor Reddy for his stimulating presentation. Covering all the aspects of this rehabilitation and others. Now I want to take you to the Himalayas, central part of Himalaya, where we are facing lots of geological disasters or natural hazards due to different geophysical and meteorological processes. So thank you for your kind introduction. So I will just jump to my presentation. In the picture, you can see that this is one of the largest landslide in Nepal, Himalaya, due to excessive rainfall, and people are living and coping with this kind of natural hazards in this part of the world. So briefly, I suppose most of you know that this is the cross-section of the Himalaya, starting from Tarai, what we call Indo-Gangetic Plain, to the top of the world, Mount Everest. And so if you see on the cross-section, these surface topography is controlled by tectonic subdivision and tectonic moment with this, fault thrust in extending or running through all Himalaya from east to west. If you look the moment, Indian plate and the Eurasian plate, and just assume we fix the India, and then you can see the velocity that moving every year, millimeter per year. And what you can see here in the middle part of the Himalayan arc, we have the highest, like 16, 18, 17 millimeter per year. So that's how these places are very, very vulnerable in terms of natural hazards, which are already coupled with Asian monsoon, and then aggravated the problems that people are facing for centuries and centuries. If you look at Nepal, you can see that this is divided into three parts. In the northern part is the mountain, and then the middle part hill and the Tarai. So these geomorphological features, you can easily understand what kind of natural hazards are happening there. In the southern part, we have flood, and in the northern part, mostly landslides and debris flows. And of course, earthquake is there, which is 2015 remarkable earthquake, the recent one. And this is the geological map of Nepal, where you can see the different thrusts and faults. The lithology ranges from sedimentary rock to igneous rock and metamorphic rock, which are already weathered and then deformed due to different phases of deformation in the Himalayas. You can find D5 or D6 level of deformation in Nepal or in the Nepal Himalaya. So if you see some of the largest landslides or the mass movement, you can see that, in the very long time, 10 to 4 years before, there was a Chergori landslide, which actually melted its slip surface, the sliding surface. And then, then we have 30 to 40 years, some of the largest, and then post-glacial phases, some of the largest landslides are there. And then in the modern history, also, we have different large scale landslides due to these tectonics and the meteorological processes. Some of the pictures, what you can see, debris flow in 1993, and you can just imagine the amount of debris here, and there's a people standing here, and you can take a reference scale, and then you can easily guess the the size of the boulders. And then the famous, Jure landslide, which is one of the largest landslide in Asia, that occurred in 2014, which dammed the Butikosi river, what we call Sunkosi river as well. And then another one by Gorkha earthquake, Langtang village was just swept away with fall from debris and ice, and then it destroyed the whole Langtang village. If you look on the Google Earth images, some of the largest lakes that were formed due to these large scale landslides. So here you can see the Faksundo Lake in the western Nepal. You can see this is the lake, the blue color, and then the yellow shaded area is the landslide deposited mass. Not only that, if you look another landslide dam lake, here again this landslide dammed this the river and formed this Sapo lake. So this kind of phenomenon are there. But recently what we saw in Uttarakhand in Chamoli, we had a similar kind of hazard in 2012 in Seti River, in the western part of Nepal, where the famous Pokhara city lies. And you can see here on the red box, this part of mountain just fell down and then mixed with this debris, and this you can see at the bottom, this is the illustration. And this is the yellow part is the Pokhara Valley, old deposits of Pokhara Valley. And if you see that event in 2012, you can see that the amount and the extent of this, the flood, which actually destroyed these breeze later on. I will show you one photographs here, and you can see the comparison before and after. So this is all the debris after that event. And you can see the beautiful picnic spot where we have hot spring, and it was totally collapsed. So these kind of scale the phenomenon that we are experiencing in the Himalayas. So, and then, we thought that, we need to study on these formation of this Pokhara Valley. And then we studied I studied with my German colleagues from Uni Potsdam and GFZ Germany. What we did, we tried to identify all the sedimentary signature of these sediments to identify the process of formation of this beautiful valley in the Himalayas. Because if you see from western to eastern Himalaya, there are different kind of valleys, but might be similar kind of origin. And we investigated the sedimentary signature, and we found some charcoals, and then we did the carbon isotope dating, and then we did the beryllium-10 dating, because there's one big boulder, and then we did the beryllium-10. So luckily, our data are coincides with the large scale earthquakes that were reported by the previous researchers. And then we concluded that this valley was developed due to these last three earthquakes in 1100, 1255, and 1344. So this is the first time that we found the sedimentary signature of earthquakes in the Himalayas, and which was published in Science in 2015. Not only that, if you see the large scale rock slide or the geomorphological features in the Sagarmatha National Park, you can see the large scale movement. And now also you can see the different geomorphic imprints over there. And if you look closely again here, you see the slope direction, and you can see this deposition of the materials. And what we have done, we have prepared all this, geomorphological and engineering geological mapping to understand the process of this kind of large scale landslide. So these were the, some of the large events that we experienced. There are some of the examples. So in 2015, we had a large earthquake, 7.8 ML earthquake. Here you can see this is the epicenter, and another is the major shock, aftershock. And you can see these dots are actually polygon of the co-seismic landslides. And these are aligned in one direction, what we call earthquake directivity. And then these landslides are reactivated by the subsequent monsoon of the subsequent years. And then we started to understand what is the, the settling time, or what we call relaxation time in the mountains. I'll give you one example here from Chichi earthquake in Taiwan, 1999, and it took nearly 5 years to settle the mountains. So we didn't know this kind of information in the Himalayan part. So we installed broadband seismometer. We studied the sediment load in the river system, bed load, and everything. And then we are doing our study all of a sudden in 2016, there was a glacial lake outburst in the Tibetan part, People's Republic of China. And these, you see, this is the border between Kodari Friendship Bridge, which is border between Nepal and China. And the lake was burst here. And you can see these, the material or debris or the flood just travel to the downstream. I'll show you some of the photographs that were captured by our time-lapse camera that we installed to understand the morphology changes. And here in 2016, 5 July, you see the river and then the sediment and the water. And then in 6 July, you can see the flood. So this is particularly important because, you know, in the Himalayas, it's a long-hanging discussion whether the long-time rainfall are really responsible to change the landscape or one single event can change the landscape. And we did this, surface scanning using terrestrial lidar scanner. And you can see, so we did the before and after monsoon for 3 years. Here you can see the blue color is the erosion and the red color is the deposition. So in the upstream or near to the border between Nepal and China, you see lots of erosions were there. But if you go down, you can see this is the blue color, and so there's an erosion, and then the deposition took place another side of the river, which ultimately changed the river course, and then the bank failure, and then we had landslides along the riverbed, or in the slopes, banks. And if you go on down, a little bit down, I'm just showing some of the representative analysis. Here also you can see the channel shifting. So what's the meaning of this? If you see the comparison in different years, for example, 2011 to 2016 with different colors, there is a landslide area, but particularly the bottom graph is important. Here you can see this blue line, which denotes the 2016 channel width, which changes from 29.5 plus minus 3 meter in 2015, and then it changes to 41.3 plus minus 3 meter in 2016, which is a big change. And then I'm not able to present everything here, but there was a big boulders that were not, they were there, but this flood just removed these boulders and everything. So, there's a high level of data that available that's published in Science in 2018. If you are interested, I can share to that. So it shows that the one single large scale event can be responsible, or is one of the most responsible factors to change the landscape in the mountains, especially in the Himalayan region. So after seeing these kind of pictures, I will take you to the long-term landslide variation in the Nepal Himalaya. So, to see the photographs by earthquake, co-seismic landslides, especially shallow landslide in 2015. But if you look on the long-term data that are available in decent manner, and then the Ministry of Home Affairs, Government of Nepal, you can see these events and dead people. So these are the fatal landslides. So from 1971 to 2020, interestingly, you can see that these number of landslide events and the death people or fatality increases after 1990, because after that, actually, the age of hill road construction started, what we call bulldozer engineering. So the bulldozer driver is engineer. And so these local political leaders, they are just, ask the bulldozer driver to make a road without any engineering investigation or geological investigation. That's how it can be. But this might be related. The technology has improved. People have mobile phones, internet, telephones. So they reported to the data recording system. But above all, if you look the trend of the landslide here, the trend line is increasing. So, this is one of the fundamental things that we need to understand, why these are increasing, how we are constructing our road. And one of our study that we published in 2018 shows that most of the landslides, they occurred within 100 meter left and right from the road. So obviously the anthropogenic activities, the road construction, are one of the major responsible factors. Of course, the changing rainfall pattern also responsible, and inadequate agricultural practices, or people have already forgotten these kind of indigenous knowledge that our ancestors were using in the past to control the water movement in the mountains. Now in the name of modern development, everything was ruined. So this is one of the biggest lessons that we learn, and we need to incorporate these in our infrastructure planning. If you look the spatial distribution of the landslides in the Nepal, you can see most of the landslides are concentrated in the mid-hill region of the mountain or the Nepal, which shows that these places are tectonically kind of active because there's a main frontal thrust and main boundary thrust. And most of the people are living in the hill, so there's anthropogenic activities and infrastructure development. And then, of course, if you see the total number, there are more than 4,800 landslides occurred, killing more than 5,700 people. And even in 2020, the monsoon, we lost 303 people. So I will show you some of the photographs of 2020. But before that, let's see the road construction practices. I don't know, maybe it's similar in other part of the developing countries, but here in Nepal, you see, we build our road, but we don't care about the large, topographical signature or geomorphological signature. And this is the second photo here. You can see the village is up there, and then on the bottom we have a landslide. But now again, we are considering these kind of, I don't know what kind of terminology you want to keep. You can coin any term, So this kind of, bad road construction practices is really killing this Nepalese geomorphological landscape. And you see the construction practices also. And one of the particular picture here, photo here, you can see this is one of the major road connecting Lumbini, Pokhara, and then to China. But you can see already the road and then the slow failure already there. So, what went wrong? How we are constructing our roads is the major important question. Not only that, 2020, you see, these are the landslides that we faced. Debris flow, shallow gully erosion. The reason might be different. People are considering that community forestry program might be one of the good. Yeah, for the preservation of forest is quite good. But what about the soil moisture changes or water holding capacity changes of the soil over the time when we build our forest? How are our water management systems are working over there? How we are building our houses in the mountains? These are the important things. And how we are tackling with the climate change, with the erratic rainfall and changing the rainfall pattern over the long period of time. And these are the important things that are really aggravating these kind of problems in the Nepal Himalaya. So, but after all, we have a very beautiful future, beautiful mountains, snow-capped mountains. This is the photographs that I took in the hidden valley, hidden paradise, or forgotten paradise, what we call the Kaligandaki Mustang. The photo is facing towards south. And we had this beautiful landscape. But to preserve this beautiful landscape, we need to work together for sustainable risk reduction in the mountains, not only in the Himalaya, Nepal Himalaya, but all the Himalayan parts of the world. So these are my coordinates. You can reach to my email, and you can just log on or just click my personal web page, and I'll be happy to collaborate in the futures. And I'll be happy to have any questions if you have. Thank you very much. I stop here. Over to you.
Yeah, thank you, Dr. Adhikari, for excellent presentation. And I can also understand how the behavior in the particularly in the Himalayan region is how much complexity is there. So, but you have touched the various aspect in the very fundamental manner, like all the geological and in the last you have explained the way to construct the infrastructure in that particular region. So it's very informative, I think, and it's excellent. And so actually we have I would like to request all the audience, you can contact Dr. Adhikari for any query related to his presentation or for other further collaboration and all those things. Okay, so with this one, I would like to thank all the speakers of this keynote session 5, Dr. Arjun Sil, Professor Darren Sian, Professor G.R. Reddy, and Dr. Basant Raj Adhikari. Thank you very much, all of you, for your time and your nice presentation. And thank you very much to Dr. Sri Bhalsaji and organizing committee for giving me an opportunity. So I'd like to pass this the floor to the Dr. Sri Bhalsaji. Yeah.
Thank you, Arvind ji, for the excellent moderation and for kindly chairing the session very efficiently. And thanks to all the speakers for their excellent lectures, and special thanks to all the participants. So because we are seeing now 5 keynote sessions are over and still we are having around 250 participants in every session. So every day 4 hours keynote sessions and 2 hours of technical sessions. So thanks for your enthusiasm and overwhelming response, participation and interest. So we owe a lot to the participants who are making this event a great success. So thanking all of you, let me just share the poster of today evening's session, keynote session 6, which will be chaired by Dr. Darren Xian from NUS Singapore. And we have 4 speakers, as you can see, Professor Jasmine from NTU, then Professor Jasada from Thailand National Electronics Technology Center, and Dr. Amarnath Hegde from IIT Patna, and Dr. Piyush Swami from NIT Patna. So we look forward to see you all for the keynote session 6, today 6 p.m. Indian time. And also the technical sessions will be running parallelly. Technical sessions 5 and 6 will be running parallelly from 2 to 4 p.m. So I hope the link is already emailed to all of you, or you can just check out our website. So thank you once again. I think we can stop here. Chandan sir. Yeah, sir, you are muted. Your mic is muted, please. Yeah. Yeah. Fine, sir, fine. No problem. So thank you all the participants. So we will meet you in the evening. Thank you all. Thank you. Bye. Thanks, Arvind ji. Thank you.
Yeah, thank you, Valsaji. Thank you very much. Yeah.
Very good, very good. Today, what happened was that the timer, no, usually when we log in, automatically a message comes for running the timer. Today, that message didn't come. It came, it was distorted. So it was not directing, but again stopping, no, it may, because already so many people have joined, so I did not reboot it. Yeah. Fine.
Okay, thank you, Valsa ji. We'll see you
Okay,
again.
Arvind ji, thank you very much.
Okay, bye.
So thank you. Chandan sir, your mic is muted. Oh, I think I have made you the co-host. I think in between, no? You were maybe in now please try.
Oh, now it is okay. So just thank you very much, Dr. Arvind,
Yes.
for nicely conducting this session on time. And moreover, we would like to tell to all, as we have discussed in the group, VCDRR group, that all the participants, they are not only keep us alive and effective, but we request all the participants that to be there on the special session, especially this validity session also, where we would like to have, there are about 10 screen I can see. Each screen shot will take with their video on, and then that will be taken as a group photograph. Like there are